Hello guys, good evening. Okay then, as anyway we have discussed the method of joins. Today, tell me one thing. Do you guys want me to take Friday's class or shall I take on Sunday? Just by concerning about others.
Monday will be fine, sir. Because Saturday we are having two exams, morning session and
Yeah,
afternoon session.
that's
So
why I'm
it will be-
telling. If you guys want, I won't take Friday's class. As 27 your exams, okay, no class on Saturday. So after that, either we can again start from Sunday or Monday.
On
It's
Sunday it will be fine, sir.
yeah,
For
it's
me it is okay.
yeah, it's upon your interest, guys, only. So if you guys are not attending, then let's see, Vishnu. If everybody is okay, then it's fine. But if not, then it's fine. One day we can manage. That's what the problem with this class is that, okay, even though if we have some basics, then we can understand, but that's not how it ends at the end of the day. It's feel like if we are missing one class, it's like we are not understanding any other classes. That's why my worry is about if I want to teach geotechnical or if any other subject, then I might not have concept this much. You know why? Because every chapter can be discussed with some introduction and then with some formula, then we can continue. Meanwhile, I think I have gave some tasks to you guys.
Yes, sir.
So can you guys please respond with regard to that? Good evening, Andal Guru. Thank you. Welcome.
Sir. Good evening, sir.
So any idea? What is the question that I have given to you? I didn't remember actually.
Sir, you asked us to find any other methods other than this in finding reactions, in finding the member forces.
Okay, thank you for reminding. Okay. Do you guys have anything to discuss about that? Anything doesn't matter. Just give a thought. Or
By taking moment at any joint, we can find some answers.
can you please elaborate more? What do you mean by movement at any point?
Moment about A. We can get some reactions, sir.
Movement about A, which we have already found reactions, right?
Yes, sir. But you told us to find out any other new methods.
That means you are saying to find the support reactions only, right?
Yes, sir. Yes, sir.
I think the way it's same, right? It doesn't. The way we have found the support reactions, if you take moment anything, that's what we will get it at the end of the day.
Yes, sir.
Come on, guys. Any other ideas? Oh, it's great. 6 people have joined. Devi Perumal, is it your first class? Or I didn't notice you. Sorry if I pronounce it wrong. Am I audible to you guys? I'm audible, right?
Yes, sir. Audible, sir.
Yeah, thank you. Okay, I think I have received. Yeah, fine. Thank you, Anita. Okay, then let me give you one traditional trust problem. Tell me about zero force members, okay? How many zero force members are there and what are they? Can you guys quickly find out how many zero force members are there in this case?
Sir, I can find one. Member EL.
Member AB?
Member EL.
Only one.
Sir, no, sir. Only one. Not okay, sir.
This is just everything I'll say the same. Take a pause, think about it, get back to me. Look at it carefully. Identify what are those 0 force numbers and then let me know. Are you guys seeing any, except the diagram, are you guys seeing anything on the screen? Like number of participants? No, right?
No, sir.
Okay, then fine. Devi Perman, can you please respond? Is this your first class? Even you can type whatever you want to say.
Sir, 4,
Yes,
I
please.
think 4, sir.
Just tell me the count.
Uh, sir, E to L வந்து
No.
L
Just tell me the count first of all.
4,
Let me
4,
hear
sir.
from others.
4.
4 from Manita.
Yes, sir.
From Anita, number of 0 forces are 4. It's not an option A for Anita. About others, as I'm telling you, it doesn't matter whether it is right or wrong. Only the matters is whether you guys have thought about it or not. That's what it matters a lot. Everything will start from just a thought. I think there's the response. Yeah, Vishnu, from Vishnu, it is 10. Okay, Vishnu. I need to respond. I need response from all of you, not from one. From Priyadarshini, Ramya,
One,
Andal,
sir.
for Priyadarshini, Andal Guru, I am representing AG, Ramya, I am representing R. If Devi Permal response, then let me give it for D. Priyadarshini, have you gave a thought about this?
Yes, sir, counting, sir.
Okay, cool. No problem. Take a minute and let me know. Andal Guru, what about you?
Sir, I couldn't find. Simply I'm sitting.
Okay. How many you found? How many you found at least as of now?
Sir, only one, sir. Other
Okay.
than I couldn't
Okay.
understand and realize.
Okay. Then let it in a square box. I think the one you found is EL. It seems.
Yes, sir, simply EL. And above MHR, the load, the member above the load. I'm thinking
Yeah.
about in that way.
Yeah. Just think about it. It's fine. I think Priyadarshini, what about you? Ramya?
Yes, sir.
Yes, please. Both of you, what happened? It doesn't mean that you have to take so long, right? At
Sir,
least
is it 2, sir?
2. Are you
Yes, sir.
still counting or are you finalizing your answer or you have just found until 2?
Oh, finalizing, sir.
Okay. Priyadarshini, about you?
More than 14. I
More
think
than?
15 something.
How many
15.
members are there? I didn't realize. I think it's very far number it seems.
Even the smaller things are members, no, sir.
Yeah. They are all members.
Uh,
There are no overlappings at all. Okay, then let me see. Okay, I think.
Sir,
I thought
10.
I think 13 things. Sir.
10.
My count is 10, sir, now. On the BC, CD, and DE.
Okay, let's discuss. You count is 10. Okay, let's see. It's great that nobody answers are matching except for Vishnu and okay, I think no need to explain for this member, isn't it?
Yes, sir.
What is the condition? Actually, we are discussed about.
No load acting on the member and 2 collinear.
We have to come if 3 members are connected at a joint
Yes, sir.
and
1 collinear force.
2 are not
Member.
collinear and
3
1 will be
members are
non-collinear.
connected, then 2 should be collinear,
1.
1 should be non-collinear,
Yes, sir.
and
It will be 0.
one more condition. What is it?
No force acting on the member.
No load should
No
act
load.
at that joint. Then only that is possible. So first of all, if you look at that joint L, how many members are connected? 3.
3.
What is the non-collinear member?
LG.
Is there any load acting at this joint?
No,
No.
sir. No.
That's why this member does not carry any force. Right?
Yes, sir.
Now, I think I should give you some more joint. L, M, N, P. Now, look at this joint N.
Sir,
TN
ND
will be zero, sir.
ND will be 0.
These two are collinear, isn't it?
Yes, sir.
Yes, sir.
This is non-collinear. There is no load acting at this joint. So that's why it won't take any force. Everybody will agree that
Yeah.
force in this member
Yes.
is 0. Whoever don't agree, then let me know. We'll discuss. Similarly, look at this joint. How many members are connected actually? 1, 2, 3, 4, right?
Which joint you have to say, sir?
4 members are connected. But what about the force in the member Dn?
DN.
0, right?
Yes, sir. Yes.
If it is already 0, then why do we have to count about it? Then at joint D, it becomes how many members right now? After
4.
we have
4.
3,
even
sir.
though-
3
even
members.
though-
Without
yeah,
the 3, yes, sir.
even though 4 members have connected there, but still member D and as it does not carry any force, then even if you draw the free body diagram at joint D, you won't represent any force Dn. Why? Because the force in there is
0. 0.
that's why DC and DE collinear or not? DC and DE collinear members.
Yes, sir.
Collinear.
And then what is the non-collinear member?
DO.
DO, sir.
Then what is the force in that member? Is there any load acting at the joint? No.
No load, sir.
Then what about the force in this member? 0. Now look at the joint O. And can you tell me at joint O, is there any zero force in the member?
Okay, and OE.
S please.
OC will be zero, sir.
OC will be 0, sir. Non-collinear.
Yeah, as OC, so even the 4 members are connected, DO, 0 force member, there is no lag acting at that joint. Second force in this member is 0. I'm just highlighting with this color. And similarly, look at the joint C. In the same way, can you find anything?
C being
Same way,
CD,
sir.
so CK, same, sir.
PK
0.
same,
Same,
0.
0,
0, sir.
right? Now,
Yes,
look
sir.
at this joint K. How many members are connected?
1, 2, 3, sir. Except
Even though 5
this
members are
KZ,
connected,
because
even though 5 members are connected, force in the member CK is already 0.
yes,
When we
sir.
apply this logic, we cannot. Why? Because at joint, how many members are connected?
4.
1, 2, 3, 4. So we cannot strictly apply that joint, that rule. And similarly, can we apply at the joint F, at the joint P, at the joint G, at the joint Q, at the joint H? What are those 0 force members? This is the 0 force member.
PF will be
This is the
0,
force
sir.
member. This is the 0 force member. This is the 0 force member. And this is also a 0 force member. So this is 0, this is 0, this is 0, this is 0, this is also 0. Isn't it?
Yes, sir.
Am I right?
Yes, sir.
So total how many are there? 1, 2, 3, 4, 5, 6,
10.
7, 8, 9, 10. Is it okay?
Yes, sir.
Yes, sir.
How come
Yes, sir.
Vishnu? What are those extra 2 members that you have represented in this case?
Vishnu told only 10 things.
He told only
He
10.
is
but
talking
I
after
think
12.
Yes.
in the chat box, I think he represented 12. BK, it won't be 0, right? Why? Because at B,
There is a
force is
load
acting.
Acting on load, sir.
So that's why it won't be 0. And still, can you somehow increase number of zero force members by doing some changes? By doing some changes, can you identify? Or by doing some internal changes, can you increase the 0 force member further? Or how can you decrease this count? Is my question clear?
Yes, sir. Clear.
Right? Any thoughts? What happens if the load is here? Where the change is going to occur?
Then
Can
zero
you tell me?
force member.
First of all,
is
tell me
produced.
which members I have to remove from 0 force counting.
CK.
Sir, CK, sir.
TK? Okay.
Yes, sir.
Right. Okay. And then
That's it, sir.
that's
No,
it.
Debo.
no, sir.
Just think about it.
HM.
Meanwhile, let me draw this picture. MH, what do you think about MH?
Yeah, yes,
Yes,
sir.
sir.
That can be removed, sir.
Right?
Yeah.
Let me remove it too. What's happened to them? Yeah, I removed this too. And any other that you can identify? Nothing, isn't it?
Yes, sir.
Let me see. CK and HM, yeah, that's fine. Okay. Can we move on to method of sections? So what is the difference by taking the headings itself, method of joints and method of sections? Let us just simply understand with simple example. Joint A, B, C, D. Now, it is a determinate truss or indeterminate truss?
Determinate, sir.
Determinate. I think everybody will agree to it. Now, method of sections means previously what we have done, we have taken the free body
Joints.
diagram at a joint, isn't it? If I'm
Yes.
talking about a joint, at that joint, I have drawn the free body diagram. But here, as it is a method of sections, instead of taking a point, we have to consider a section. I think you guys can identify what is the difference between a joint and a section.
Yes.
Suppose let us say, if I divide this truss into 2 parts, then how it's going to look like? Let us assume that I haven't found the support reactions, isn't it? If we separate those two, that's how it looks like. Can I call it as a section?
Yes, sir.
Sir,
Yeah, please. Okay. Now, as I'm separating at this joint, do you have to represent the forces or not?
Yes, sir. Yeah, to
As
represent.
I'm separating this
Yes.
entire truss along this section, what I should do? Obviously,
Internal
as
forces.
I'm separating, I should represent the forces, isn't it? Now, initially, let us assume that if I'm assuming the tensile forces in everything, what is the force in this member? Similarly, this is also the same member, so I have to represent the same. What should I call this? This is the force in the member AB. Similarly, if I assume a tensile force here, and if I assume a tensile force, what I should represent? This is the force in member TP. Similarly, if I represent like this, if I assume a tensile force, so this is what I should consider it as a force in member CD. Now, before moving on to discussion further, let me consider this as section 1 and this as section 2. Left side part I am considering it as a section 1 and right side part I am considering it as a section 2. Right? If I am saying that my entire truss is in equilibrium, or if
Yes,
I am
sir.
saying that my entire truss is stable, then based on that, can I say that my section 1 is stable and my section 2 is also stable? Can I say? Can I say it or not?
Yes, sir.
Everybody will agree to it,
Yes, sir.
right? Now, look at the section 1. If it is to be stable, then obviously what we should do? It has to satisfy the
Equilibrium
equilibrium
equations.
equation. Now, the point is how many equilibrium equations that we have to consider here. Previously, how many equations we have considered?
2.
2, right? What are those two?
Summation fx, summation fy.
Right. Why we have ignored the summation of moment?
That means stress action.
As all the forces are passing through the common point, then there is no point of generating movement. But here, as we are talking about a section, we are not drawing the free body diagram of a joint. We are drawing free body diagram some particular section. That means all the members will not orient along the same line of action. Can you see? The line of action for member AB is like this. Line of action for member CD is like this. Line of action for member CD is like this. So, as we are talking about method of section, the members might not have a common line of action, then rotation will also be possible. That's why if you want to consider a section, if it is to be stable, then you have to consider summation of fx equal to 0 to stop the rigid body motion along x, summation of fy is equal to 0 to stop the rigid body motion along y. Similarly, summation of moment along z is equal to 0 to stop the rigid body rotation. So, if we are talking about method of sections, how many equilibrium equations we have to consider?
3, sir.
We have to consider the 3 equilibrium equations. Now, as we are having 3 equilibrium equations, how many unknowns we can find?
Unknowns.
How many equations we have? 3. So that's why
Yes, sir.
we can solve unknowns up to 3. That means if you are talking about method of sections, if you are talking about method of section, if you are considering the equilibrium of any section, then how many unknowns or how many number of members should not exceed or number of unknowns should not exceed 3. Why? Because as we are having only three equilibrium equations. After drawing the free body diagram of the section that we have considered, it should not have not more than three unknowns. Now, look at the section 1. How many unknowns are there? If you look at the section 1, can you tell me how many unknowns that you guys can see?
The section 1, so all member are considered, sir.
All?
5.
Number 5, sir. 5, sir.
What are those?
2 reactions and
Two
3 member
reactions, 3
forces.
members.
Now tell me one thing. Am I separated support from the truss?
No, sir.
Am I represented the support or not? I am represented, isn't it?
Yes,
If I
sir.
am representing, then how can you guys count the reaction forces there? That's what the what free body diagram says.
External
Yeah,
support. External
where
support.
whatever you are removing, there only you have to represent the action of the forces. Here I am not removing the support. Then how can you guys tell me that unknown reactions here? Forget about it. Look at the section itself. Forget about the support and look at the section. How many
3.
members are there?
3, sir.
Three.
3.
FAB, FCB, and FCD. Similarly, even if you look into the right part, as this is a simple truss, that's why I can look at
It can
as
also be 3.
they are also same, right? So as three members, as three unknown forces are there, then I can find those three unknowns by using the equilibrium equation. Three unknown means three members, isn't it? If
Yeah.
three members are there, then only you will get the three unknowns. That's why what you have to make sure, if you are solving a problem by using the method of sections, you should not cut. How many? Not more than. How many members? 3 members. Why? Because not more than 3 members. If I cut a section with more than 3 members, then what is happening? Number of unknowns will be more than 3. If number of unknowns are more than 3, then can we solve it by using equilibrium equations?
Not possible, sir.
No, not possible. That's why whatever the problem, if you are solving by using method of sections, make sure that you must have to see. You should not cut not more than 3 members. But
3.
still, there are some exceptions. I will discuss with an example. That is what given in one of the problem in GATE. That will discuss with an example later. Those are very, very, very few exceptions. But this is the minimum basic criteria. What is that criteria? You should not cut not more than 3 members. Now, let me draw the section 1 separately. Okay. Yeah, as I have discussed that you guys have separated a section like this and you have represented this is the force in AB and this is the force in CB and this is the force in BC. Now, apply the equilibrium equations and can you tell me what are the forces of AB, FCB, FCD? Let us say that there is a load acting at this joint 10 kilonewton and there is a load acting at this joint is also 10 kilonewton. As this will come onto the picture. Can you tell me these unknown forces? Can you or cannot in this case?
FAB is 0 forces.
If AB is 0 force, why?
The vertical load 10 kilonewton is taking care of, that means collinear forces.
Yeah. Again, you are looking at method of joint. Now we are talking about method of sections. Forget about method of joint. Why I have taken simple problem is that to get complete clarity. Later on, if I give you some big stress, then there you just have to think about it. Now, tell me, what is the equation that if you take summation of x equal to 0? Can you tell me?
FTC plus
FAB.
Plus FDC is equal to 0.
FTC plus FA.
Okay. And if you take summation of fy equal to 0,
We can
how much will get it?
sir, we can resolve FCP in different horizontal directions, sir.
That
It's
is
possible.
okay. Yeah. You can resolve this component into horizontal and vertical.
So see, summation FA equal to 0, that will be 2, sir.
Summation
FY equal to 0, FCP sin theta
FCB sin theta
minus 10 equal to 0, sir.
Yeah. Is it right? Yeah. Now, the thing before we want to apply the equilibrium equations is that, not only here, whenever you are applying the equilibrium equations, first thing we have to make sure that we have to consider all possible forces that are acting on the system. That is applied forces, reaction forces, and then internal forces. Here you have represented the internal forces. You have
Sir, I have one
represented
doubt,
the, yeah, please.
Sir, could not consider an reaction. Support reaction not considered as sir.
We have to, that's what I'm telling you now, is that remember, whenever we are solving the method of sections, or if you remember, while solving the equilibrium equations of antitrust, we have considered the all possible unknowns. That means, let us say, if I apply the equilibrium equations of antitrust, I have removed the supports and then I will represent the unknown support reaction from the supports. Just like in the same case, always remember that even in method of sections, before applying the equilibrium equations, we have to consider the effect due to all possible forces. All possible forces are either from applied loads, internal forces, or support reactions. Here we have considered the applied forces. Here we have considered the internal forces, but this we have omitted in this case. So make sure that you have found the, or you have to represent the support reactions before applying the equilibrium equations. So the same problem, I want to redraw it again, but with two different conditions. Let us use the number A, B, C. Both are stable or unstable, determinate or indeterminate,
Stable and determinate, sir.
stable and determinate. That everybody will agree, right? Now, let us assume that the loads are acting at joint B. Let us say this is 10 kilonewton, and here also at this joint it is 10 kilonewton. First thing is, can I consider a section like this? Can I or cannot? This is the first question that I want to ask you. If I separate this section from the truss, how it will look like? It will look like this. Whatever the force in this member, this is the force in member AB. And what is this? This is the force in member AC. Can I cut a section like this? If I cut a section like this, how many unknowns are there?
Two unknowns, sir.
Two
Sir.
unknowns. Can we solve it by using equilibrium equation?
No, sir.
Why? We
Two
are having,
unknowns and three equilibrium equations.
yeah, if we are talking about stability. But here the point is, those two members are meeting at one joint, right? Yeah, Vishnu, that we'll discuss. Just take a minute, we'll discuss. Here, see the force, see the member AB and member AC. Are they passing through common joint or not?
Yes, sir.
Yes, sir. Common joint.
If they are passing through common joint, why can't I call it as a method of joints? That is what we have discussed, isn't it? If all the forces are passing through common joint, then how many equilibrium equations we have? Two. What are they? Summation
Summation
of
of
x is equal to 0,
Summation of
summation of y equal to 0. Then how come this can I consider it as a method of sections? Strictly, I can say it as a no. Why? Because as all the members are
there are
passing through
unknown.
the common joint, then there is no point of considering summation of moments is equal to 0. So the first point, whenever you are cutting a section, first thing that you have to thought in your mind is that, what is it? Can you, based on this example, can you tell?
Do not pass through a common point.
Yeah, all the members should not pass through a common point. So if they pass through a common point, then what is happen? It is becoming
Under
like a
method of joint.
method of
Joint.
joint.
method of-
So this is not the best choice that I have to consider. Everybody will agree to it, right?
Yes, sir.
Now, can I consider like this? Can I consider a section like this? Can I? So imagine
Yes, sir.
if I separate this part with respect to this section, then how many members it is cutting? Or
Three.
how many members
Three,
it is
sir.
cutting? Three. AB, CB,
A, B,
and
C,
CD.
B, and C.
Are they meeting through common point?
No, sir.
That means it is a possible section that we can consider. And second thing is that how many members it is separating?
Three
Three.
members.
That means if I consider the equilibrium of a section, I am having three equilibrium equations. That means I can solve up to three unknowns. So that's why this is one possible way of considering a section. Everybody agree with this?
Sir.
Now, after that, the next thing you guys have to consider is that find the support reaction. While considering the equilibrium, as Vishnu, while considering the equilibrium, we have to consider the effect of all forces. We have to consider the support reactions. That is why. Now tell me, quickly, can you tell me what is the vertical reaction at C?
PSC and solve the
What is the vertical reaction at C? Look at the entire truss. Don't look at the truss. So before,
sorry, FPSC minus
what I'm asking you, what is the
Five,
vertical reaction
five.
at C?
5 kilometers.
five.
This is the first problem that I am going to discuss. This is the second case. In first case, what is the vertical reaction at C?
10 kilonewtons, sir, on port, sir.
C. see the support at A. Will it resist any vertical forces? See the support here. What is the type of support? Roller support.
Plus support, sir.
Rollers are placed along which direction? Vertical or horizontal?
Vertical direction. Vertical direction.
That means, will it allow? It won't take any vertical forces, isn't it?
Yes, sir.
So vertical forces are taken care by which support?
Hinge.
At C. So that's why, so one vertical applied force 10 kilonewton. How can we balance this?
Upward 10 kilonewtons, sir.
By upward 10 kilonewton. Now look at these two forces, 10 kilonewton and 10 kilonewton. Equal and opposite, isn't it?
Yes, sir.
Now these two are trying to rotate your member in which direction?
Clockwise.
Clockwise, with magnitude of
30 kilonewton.
10 into 3, 30. Then these support reactions have to balance them. If they have to balance them, then they have to act in anti-clockwise direction. If they have to act in anti-clockwise direction, that means here the force should be left side and here the force should be right side, isn't it?
Yes, sir.
Now what it should have, what is the magnitude of this force? Let us say if this force is F. What is the couple it is generating? F into 3. That should be
Yes,
equal
sir.
to 30. Then what is the net force that you will get there? What is the force that you will get here without any calculations?
10, sir.
10 into 3, 30. 10 into 3, 30. Clockwise and anti-clockwise. Is it fine?
Yes, sir.
Why you guys are saying in a doubt? Yes, there is a lot of gap. Yes, why not with full confidence? Okay, let us come here. If you look at the truss 2, which support will resist the vertical reaction? First of all,
Both the
C.
supports.
both supports C and D.
Sorry, C.
What about horizontal?
Then there will be only C, sir.
Only C. Is there any applied horizontal forces there?
No, sir.
It is 0.
That means what is the horizontal force generated here?
Zero.
So there is no horizontal force. Even if I want to represent, I can represent it by using 0. Now, how about the vertical reactions here?
There is no vertical reaction at CS, sir.
That we can't say now. See here, we have visualized in the form of movements and thing. But here we cannot. Why? Because this load is passing through the point D, or from B it will pass through the point D, but we don't know exactly what happens here. In that case, what you can do is that imagine there is a vertical reaction C upward, there is a vertical reaction D at support T. Now apply the same thing. If I consider summation of moments at point C equal to 0, can you tell me how much you will get it? Let us assume this is 3 meter and let us assume this is 3 meter.
30, sir.
What is the moment because of VD? VD times
3 VM. 3 VD.
3
3.
anti-clockwise. So let us say clockwise are positive, as this is anti-clockwise minus. Because of this 10 into
Plus
3
10 into 3.
clockwise. So plus 10 into 3 equal to
So 10, sir. 10.
that implies what about this VD? VD is nothing but a 10 kilonewton. We are getting the positive reaction, right?
Yes, sir.
What is meant by positive reaction?
Upward
Our
direction.
assumed directions are correct. If
Yes,
it is
sir.
positive, it's not upward. Our assumed directions are positive. What is our assumed direction?
For
Upward. So upward direction is correct. So VD is equal to 10 kilonewton. And what about VC? Summation of
VC.
forces along Y should be equal to 0.
0.
How many forces are there? VC upward plus VD upward. That will be equal to only downward force 10. Then what about the VC? That is equal to 0. In this case, VC is also equal to 0. Okay. So the load is directly passing through the support D. In this case, especially. Now, let us assume that I am considering a section like this. Here also I am considering a section like this. Now, what is the difference between the example 1 and example 2? Can you find one difference?
Example 1 or 2, only one can resist a vertical direction, but
Not
example
with
2,
respect, not with respect to which forces they are resisting. Other than that, can you find any other difference?
Sir, in case 1, AB, FAB equal to 10, but in the case 2, FAC equal to 0.
I am saying L1 means left side of the section, for example 1, right side of the section, for example 1. This I am taking L2, and this I am talking about R2.
In case 2, L2,
Now look at L1, look at the example 1, and look at the supports. Support A and C, are they distributed to both the sections, or they are acting on only one section?
sir, case 1 will be acting on two support sections, but
Both
case
are
2,
acting in section, left side section.
yes sir, yes sir.
Right. What about in example 2? One support is going to
vanish.
section, isn't it? Left side section is one support, right side section is one support, isn't it? Now, let us say if I want to draw the free body diagram of example 1. What is this I should call? This is what my force in member AB, and this is what I can call my force in member CB, and this is what I can call it as my force in member DC, and there is a applied force acting here, isn't it? Now, in the first example, so this I am talking about R1. Even if you are not finding the support reactions, can we apply equilibrium equations for R1 directly or not? This is what my question. Once again, I'm repeating. Even without finding the support reactions in this case, can I directly apply the equilibrium equations to R1 or not?
Can I apply, sir?
We can or we cannot.
We can, sir.
We can.
Everybody, why? Because
Already known three unknowns and
the point is they are belong to which section? Both supports are considering, or both support going to section L1, isn't it? So
yeah,
if you want to apply the equilibrium equations, or if you want to study the stability of L1, then only just a second. Yes. So let me represent the L1 also. So this is what my force in AB. This is what my force in CB, and this is what my force in DC. The difference between these two sections is that if I am considering the equilibrium of section L1, then my both supports are coming for the section L1. So if you want to consider the equilibrium of section L1, then you have to represent the support reaction. This is what your external force 10, this is what your external force 10, and this is what your external force 10. Let us say that in the exam, they have asked you to find the portion member AB, portion member CB, portion member CD. In the exam, they have asked you to find these three forces. Okay. Now, if I solve the section R1, can I find those three unknowns or not?
Yes, sir. 3 unknown.
3 unknowns. Similarly, if I solve this section L1, similarly, can I find these 3 unknowns or not?
Yes, sir.
FCB I can find, FCB even if I consider section R1, even if I consider the section L1, by using both, then I can find the required unknown. But can you think, if you are a smart person, which one you will consider? Will you consider R1 or will you consider L1?
R1 will be a better choice, sir.
Why R1 will be a better choice?
Because if we consider L1, we need to find the support reactions first and then only we can consider, sir.
Yeah, that is why, that is what the first point that we have to observe while during the or while using the method of section. That is, if supports are falling on one section, then you can consider the, or in this case, as supports are falling on the section L1, if you consider the equilibrium of section R1, then simply you can find these three unknowns without doing any much extra calculations. But if you want to support for L1, first you have to find the support reaction. Even suppose if I give an example like this.
Sir?
Yes, please.
Sir, is it necessary to consider the section only in a vertical direction or we can take in a
No,
horizontal direction?
you can consider in any direction, it doesn't matter.
Okay, sir. Yes, sir.
Let us say here let's say this is the first 10 kilonewton and this is the first 20 kilonewton. Here in the exam, they have asked you to find only the portion member A. Can you tell me how you will proceed? Here I am not saying whether you can go for method of joints or whether you can go for method of section. You can tell me in both point of if you want. That's also fine. Only I need the portion member A and I need the portion member C. In exam, you have to represent these two forces. Can you tell me?
It will be 0, sir.
Portion member A is 0.
Yes, sir.
Why?
No, sir. No, sir.
Those who said 0, can you please think about it again and can you tell me how can they are 0?
Sorry, sir. Sorry, sir. At a joint load 20 kN acting on it, sir.
Yeah. Okay, then.
Please, sir.
Okay, then tell me. Let me say if you want to solve it by method of joints, how we will solve it. First of all, tell me whether it is determinate or indeterminate.
Determinate, sir.
Determinate. Everybody will agree.
Indeterminate, sir.
Indeterminate, sir.
Indeterminate to the degree.
1, sir.
1.
1, sir.
But still I can find the reactions, you know. Let us visualize this example in the method of joints. Again, while discussing method of joints, I told you one thing. What is it? Even if you are solving by using method of joints, first of all, you have to see the necessity to find support reactions or not. In this case, first of all, you have to understand, even without using the support reactions, can we find the internal forces or not? Can we or cannot?
We can.
We can. So what is the first joint that you will consider here?
Joint B, sir.
Joint
B.
D for dog or B for Bombay?
B for ball.
Yeah. Why? Because if it is a method of joints, you have to make sure that your number of unknowns should not be more than
2.
2.
2.
So if you look at joint D, how many members are connected?
2 members.
2. DA and DE. Right. If you use the method of joints, you can find it out. What about the force in those 2 members? Can you tell me?
0, sir. DE and
No load acting
A
at this joint.
0.
Yeah. 2 members are connected, no load acting at that joint there. What is the force in this member? 0. What is the force in this member? 0. After that, which support I have to move to? Do I have to support to A or sorry, do I have to move to the joint A or I have to move to the joint E? What is
Yes,
the best choice?
Joint E, sir.
Joint E. If you
Joint
go to
A,
the
sir.
if you go to the joint E, how many members are there?
Sir, B would be better option, sir.
B. You want to find it B.
B, sir. B.
Here or here? Okay, first I have taken a D and I have represented this is 0 and this is 0. What is the next choice? Now I'm not talking about method of sections. I'm talking about method of joints only again. Tell me which joint you will consider. A, B, C, E, F. Which one? I don't know why you guys are taking so much time today. Yesterday you guys are so good. Look at joint A. How many members are there?
2 members, sir.
3 members are connected. But out of those 3,
1 is already 0.
AD is already known. So how many unknowns are there?
2 unknowns.
So what are they? Force in member AB, force in member
And
A.
D.
Look at joint E. How many
4
members are
members.
connected?
4 members are connected.
Total
If I am saying
1
numbers,
is 1 is
5
already
members are connected, 1 is already known. So 4
So,
unknowns. That means
yes,
joint
sir.
E I cannot consider.
Yes, sir.
Now look at joint B.
3 unknowns.
3 unknowns are there. That's why again I
So
cannot.
they will be better.
So if I solve the equilibrium equations at A, I can find force in this member. I am represent with another enantiomer. And then I can represent here. So first I will consider D and then I will go for A, isn't it?
Yes, sir.
After that, which one I should go for?
B, sir. B.
B for Bombay, you mean,
Yes, sir. Yes, sir.
right? After that, then
Yes.
I can say this one and I can find this one. After that,
E. Now E, sir.
E, right? Then isn't it? Now, if you go to the member F, then how many unknown forces will be there?
3, sir.
3. What are they? Force in
1
this
reaction. 2
C.
reactions.
And then, isn't it?
Yes, sir.
What if I remove this? If I remove this, then can I find these 3 unknowns or not? Can I find this unknown and can I find this unknown?
Yes, sir. E, yeah.
Again, you guys are thinking why I can remove or how I can remove. I told you this example. What is the use of this member? Instead, I can remove that member and I can represent like this. In the same way, I can remove this member and it can be taken care by this. Now, is it easy? Or can you guys roughly can you estimate how much time it will take for you guys to solve this force in member A and force in member C if you want to solve it by using the method of joins. Roughly, can you guess how much time it will take?
So for me, 5 minutes it is taking, sir.
5 minutes, or I
Yes,
can
sir.
say I will take at least 7 minutes. Why? Because I should not commit any mistake. Why? Because taking angle, applying, see here, we have to consider equilibrium joint A, B, and then E. 3 equilibrium method of
Sir, much more time compared to session, sir, because it can be resolved on to summation f equals 0, summation f equals 0. So
Now, let us see, can we solve this problem by using the method of section?
Sections.
Just for the simplicity, every time I'm taking the angles are 45 degrees, just for the simplicity, but while solving, you guys have to take care whether they are 45 degrees or not. Okay, just be clear about this. A, B, C, D, E, F. So what is our requirement in this question? FAE and FCE. So by looking at this problem, you guys can say that the indeterminacy of this is 1. By thinking that you cannot avoid this problem just by thinking that okay, this is indeterminate problem, then I cannot able to solve it. You should not do that. Instead, what they have asked you, they have asked you to find the force in only 2 members. So as they have asked you only 2 members, then you can think of the ways to find out this problem. Okay. Now, first thing is there any need to find the support reaction? First of all, I want to ask you, if you want to solve it by using given method of sections, is there any need to find the support reactions? Or tell me when you have to consider support reactions, first of all.
Necessary, sir.
Why they are necessary?
No, not necessary.
Not necessary. If supports are not coming in your section, then why
It is not necessary.
is there no need to find the reaction? Suppose let us say I have represented a section like this. Is it a right choice or wrong choice?
Wrong choice. It comes
Why?
under method
Because
of joints.
all the members are meeting at this joint, so this is not the right choice, right? Instead, can I consider a section like this?
No, sir.
no, sir,
Why? Because
Four
because
More
members.
than
four
three,
members are
three members.
member AB is separating, member BE, member CE, and member EF. Again, as 4 unknowns are coming, equilibrium equations are can't handle. I can handle up to 3 guesses only. I cannot handle more than 3 guesses. So even if I consider a section like this, can I?
No, sir.
no, sir.
Again, the 4 members are coming into the picture, right? Now, instead, if I consider a section like this,
3.
how many members it is separating? 3,
Three.
isn't it? Now, look at the supports. Supports are falling on which direction? To the right side
Right
section
side.
or to the left side section?
Right side,
Right
sir.
side.
So, if you want to consider the equilibrium of the right side section, then you must have to consider you must have to find the support reaction. But if I take the left side section, are there any
No
supports? No.
No
If
support.
there are no support, then why you bothered with your support reaction? So if you are talented, then instead of considering the right side section, you will consider the left side part. Okay. Now let us represent the forces here. How many forces are there? So this is what the force in member AB I can represent. So this is what the force in member. Force in member A, and this is what my force in member DE, and this is what my applied forces here. First of all, let us write all those three equations, and then I will give you a hint which one you have to consider. First of all, tell me if you can consider summation of fx equal to 0, what you will get it?
AB plus
FAB plus
EE
FAB and FD, and then other than that, FA is inclined force, isn't it?
AE is
FAB
horizontal
cos theta.
component.
If you resolve that force, how much you will get it? Let us say
FA
this
cos
is theta. Then what is this horizontal component? FA
FAB
cos
cos
theta.
theta,
And
FAB
what is the
sin
vertical component?
FA sin theta.
Sin theta. Now write down the forces. For what is the equation? We'll get it. FAB
plus
plus
FDE plus
CE
FAE cos theta equal to 0.
AE cos theta is equal to 0. Now let us write summation of forces along y equal to 0. Now tell me,
20
how many forces are there
E
along?
cos theta.
Let us say upward forces are positive. So it is acting in which direction?
Downward
Minus
down.
20
Minus 20.
minus
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 FAE sin theta
AE
equal
sin theta.
As of now, just for the time being, let us don't write summation of mz equal to 0. Why? Because summation of moment you can take it any point, isn't it?
yes sir.
You can take it either at point A, you can take it at point E, or you can take at some arbitrary point here. Doesn't matter. You can take it at any point. Okay, as of now. Now, look at these two equations, summation of fx equal to 0, summation of fy equal to 0, and tell me if you are an intelligent, which one you will write first? Will you write summation of x 0? Will you write summation fy 0?
FY zeros.
Why? Because
There is only one.
One answer.
if you write summation
Only
fy
one
0,
answer.
yeah, that means you can directly find out the force in the member AE, isn't it?
Yes, sir.
So this is where the logic in method of section. If you write three equilibrium equations, if you write blindly all the equations and if you solve it, three equations you will get it. There is no doubt about it. But if you are aiming for the competitive exams, you have to think in your mind before writing the equations that in which equation I should solve first such that I can directly get the unknown. Once again, I am telling you, 100% I cannot guarantee that one unknown you will find out directly. But 80% of the time, at least any one unknown that can be found by directly with any one equation out of these three. Here, what is that equation? Summation of fy is equal to 0. That's you can, even if you are not writing this, you can directly imagine, isn't it? If you look at this diagram, look at the forces along x direction. How many forces are there? You can think, okay, FAB coming into the picture, okay, FDE is coming into the picture, okay, FAE component is also coming, okay. As these three are coming, I cannot find any, okay. I no need of wasting time by writing this. Okay, but if I look at along y direction, okay, I can think that, okay, fine. Only 20 is acting and FA is acting, okay, then I can find out that. So I will first equation, I will use this summation Fy is equal to 0. Is it right as of now? Is it okay?
Yes, sir.
Yes.
Now, even before representing the forces, as I am telling you, only vertical force is there up to 20 kilonewton, isn't it? This is balanced by force in which member? A, isn't it?
Yes, sir.
Now, what is the direction of the force? 20 kilonewton.
Downward.
Downward. If we want to be balanced, then FAE component should act in which direction? Upward or downward?
Upward.
Upward.
If I initially assume it is a tensile force, then if I resolve this component, in which direction it is coming?
Downward direction.
But to balance this, it should act in which direction?
Upward direction.
So instead, here itself, what I will do, I will represent a force like this towards the joint. Now, as I am telling you, if this angle is theta, then directly I will write it down, summation of Fy is equal to 0. That implies how much? My 20 kilonewton should be balanced by FAE sine theta. That implies what is my FAE? That will be equal to 20 by sine theta. Here, as I am taking vertical and horizontal are equal, what is my angle theta? 45. So whatever the answer, 20 root 2. And whatever the direction, towards the direction, so compression. Right? Is there any doubt for using this equation?
Doubt, sir.
Clear, sir. Clear, sir.
Clear? Right? Now, even let us say if I want to find out FAB and FDE, let us say, even if you want to find out these two unknowns too. If I'm using Fx equal to 0, am I getting any one? Even if I know FAE, again these two are unknowns, isn't it?
Sir, yes, sir.
So that's why if I use summation of x equal to 0, then there is no point that I will get the required unknowns. Then what should I do? I have left with one equation. What is it?
Moment equation.
Summation of
Moment,
moments
sir.
is equal to 0. Now here the point comes is that at which point I should consider? Do I have to consider summation of moment at this point, or do I have to consider summation of moments at this point, or do you have to consider at some arbitrary point? Let us see what happens. Tell me, if I consider moment at this point, can you tell me what will happen?
Sir, FAB will be 0. 20 kilonewton won't come.
Let me write down one thing here. Summation of, I am considering summation of moment at point A is equal to 0. That implies, even if you see 20 is acting at this point, FAB is also passing through this, FA is also passing through this. Then whatever this, we will get only
Into 3.
FDE times 3. That will be equal to 0. That implies what is my force in member DE?
0.
That will be equal to 0. If I consider summation of moments at point D is equal to 0, can you tell me what is the equation I will get it?
FAB into 3 equal to 0.
Because of FAB, because of FDE, will there be any moment? FDE.
No, sir.
Now why? Because
Passing through the
force
same
is
point.
passing through this. What about the moment due to 20 kilonewton? Again, if you see line of action of this force, this is also passing through the point D. So movement won't come. So you will have movement due to FAB and FAE. So because of FAB, what is the moment?
FAB into 3
FAB into 3, clockwise or anti-clockwise?
clockwise.
Let us say clockwise or positive. Then what about FAE? If it is inclined force, then what you should do? If you want to find out the moment in a best possible way, resolve this. What is this? Nothing but a FAE
Sin theta. Sorry, cos theta.
and then here it will be upward FAE sin theta. Again, what is happening? Plus something will come into the picture, isn't something matlab FAA cos theta times distance, FAA sin theta times distance. So if I am using summation of moments at D equal to 0, am I getting any one unknown? Or it will be equation will be in the form of two forces.
Who, sir?
2, sir.
Two. If I use summation of moment at A is equal to 0, I am getting only equation in terms of only one force. So can you correlate a logic between summation of moment at point A and summation of moment at point D? What is the logic that we can think of there? So the logic is that when moment will exist, whenever there is a
Perpendicular distance.
perpendicular distance. Now observe here, if I am talking about point A, how many members I have separated? 3 members, isn't it? In the section, FAB is acting into the picture, FA is acting into the picture, FD is acting into the picture. Now, if I am taking summation of moments at point A equal to 0, out of these 3, FAB is passing through the point, FA is also passing through the point. That's why you are not getting any moment because of FAB and FAE. So this is what the logic that you have to see is that whatever the point that you are considering the moment, summation of moments, make sure that any two members should pass through one common point. What happens if any two members are passing through one common point?
Set of joint.
If two members are passing through one common joint means movements will not generate because of those two members, and remaining you will find it out easily. Okay, that is what the logic that we are gonna apply here. But you can ask me, how can I find FAB directly? Let me redraw that diagram again. This is what my force in member A, B. And this is what my force in member AE. And this is what my force in member D, E, it seems. And this is what the force, 20 kilonewton. Now, after considering this section, if I consider summation of Fi is equal to 0, which unknown I can get directly?
FA.
FAE I can get directly. Similarly, if I want to find out FDE, which equation I can consider? I should consider
Moment about A.
summation of moments at point
A.
A. Similarly, if I want to find out my force in member AB, can you tell me which? Obviously, these two are no use, right? Summation of Fx and summation of Fy. If I am using these two, I am not getting FAB directly. Remaining equation is what is? Summation of moments is equal to 0. The point is, at what point I should consider summation of moments are equal to 0 such that I can get the force in member AB. Is it clear my question? At
Yes.
what point I should consider summation of moments are equal to 0, then I can find the force in member AB directly. Point A is out of the picture. Point D is out of the picture, right? Huh?
Yes, sir.
Yes, please. You are saying something.
Sir, FA cos theta.
FA cos theta, why we are talking about FA cos theta?
Because FAB will find it. So
You want to by using this equation.
Yes, sir.
I'm telling you, that's why. What is our motive? Our calculation should be smart. I don't want to, if I want to, let us say in the exam, if they ask you to find AB, first you should not write FY and you should not FME and then you should not, that's not our motive. Our motive is in a least possible way, I have to find my forcing member. But what is the least possible way? By using only one equation. Now tell me, this is the point A, this is the point D. Let us say imaginary lines I am drawing, these are not existing in reality as they am separated this truss. What is this point? B. What is this point? E. So what about the line of action of the member AE? It will pass through E, isn't it?
Yes, sir.
Now tell me, can I consider summation of moment at an arbitrary point E is equal to 0?
Yes, sir.
What happens if I take summation of moment at T equal to 0? Can you tell me which equation I will get it?
FAB, sir.
FAB into 3.
Because of FAE, will there be any moment at this point?
No.
Why? Because the line of action of the force is passing through the point E. Similarly, because of FDE, will there be any point at E?
Oh.
Oh, right. Now, because of FAB, what is the moment that will generate here?
FAB into 3
Clockwise or anti-clockwise?
clockwise.
Yes,
Let
sir.
us consider it is positive. Plus 3 FAB. What about this because of 20 kilonewton?
20
20 into, what is the
into,
distance between A to E?
20 into 3, 3 will be 6 or 6.
Anti-clockwise or anti-clockwise?
Clockwise, sir.
Anti-clockwise, sir. Anti-clockwise.
Anti-clockwise.
Oh, okay.
Already clockwise we have considered as positive. So
Yeah,
anti-clockwise
sir.
minus 20 into 3, that should be equal to 0. Then what about my FAB?
20, sir. 20.
Positive 20. What is meant by positive in our case?
assumed direction is correct.
This is not the reaction. What is this FAB?
Force,
Internal force. Initially we are assuming it as a tension. So
sir.
20 kilonewton tensile force acting. At least you guys got the idea
Yes, sir.
how method of sections should apply. What is the first logic? Before writing the all equations, what you have to see? You have to write only one equation in a least possible way, such that you have to find the required unknown. For summation of Fy equal to 0, you guys can directly see. For summation of Fx equal to 0 and for summation of Fy equal to 0, is there any necessity of any particular point? That means if I want to write the summation equal to 0, is it with respect to point A, is it with respect to point D? Like that it matters, or for the entire section we are writing? Am I audible?
Yes, sir. Audible.
Yeah. It is not with respect to one point, isn't it? If I am
Yes, sir.
talking about summation of Fx and summation of Fy, this is for entire section. So it is nothing to do with at what point we are doing it. So if you are writing summation of Fx 0, if you are writing summation of Fy 0, you just have to see just the forces along the corresponding directions only. But what happens if you want to find summation of moment is equal to 0? What is the difference between these two equations and this equation? How does it different? If it is a summation of moment equal to 0, the equation is depending upon the at what point you are equilibrium the movements. Either at point A, at point D, at point E, at point B, or at some arbitrary point in between. It doesn't matter. But how, what is the efficient way of selecting that point? That means if I take point A, how many members are passing through? How many forces are passing through the point A? Unknown forces.
3, sir. Point
3, sir.
How many
3.
unknown forces?
3.
3.
Am I clear?
Clear. Yes, sir.
How many unknown forces are passing through point A?
2.
2,
2, sir. 2.
2.
Now FAB known.
FAB and FAE, these two are passing through this point. That means if I write the summation of moment at A is equal to 0, which unknown I can directly identify? This no moment remaining with how many force?
One.
See, if I write the moment at point A equal to 0,
FDE.
what we are getting here?
FDE.
3, sir.
That
0,
is
0.
FDE is 0. What I mean to say is that if I consider moment at point A is equal to 0, summation of moments, because of FAB no moment, because of FAE is also no moment. So your equation will be in terms of FDE only. That's why if you take summation of moment at point A is equal to 0, you can find out the FDE directly. Have you got it now?
Yes, sir.
Sir.
Let me complete and then I will answer your queries. If I take summation of moments at point B is equal to 0, can you tell me what will happen? If I take moments at this point is equal to 0,
There
can you
will
tell
be
me
FAE and FDE, sir.
how many forces are passing through the point B?
Only one.
Only one. What is it?
FAB.
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 If I write the equation, that will be in terms of
FAE and DE.
equation will be in terms of FAE and FDE. What happens if I write summation of moments at point D is equal to 0?
How about
If I'm talking about this point, how many unknown forces are passing through this point?
Only one is passing, sir.
FDE. That means equation will be in terms of how many unknowns?
FAB and FAE.
FAB and FAE. Similarly, if I take summation of moment at point E is equal to 0, then
FAB can be found out, sir.
FAB can find.
if I take moments at point A0, only one unknown will be there. If I take B, two unknowns will come into picture. If I take at D, two unknowns. If I take at E, only one unknown. So what are the best points? What are the best points, Matlab?
A and E.
If I take which equation, then I can find out the unknowns easily.
A and E, sir.
And E.
So if you take at A, which unknown you are getting?
FD, FDE.
If you take summation of moments at E, which unknown you are getting directly?
FAB.
FAB, sir.
That means you have to select a point for summation of moments is equal to 0, such that, what is the condition?
Only one unknown.
Any two unknown members should pass through that point. If you take point A, two unknown forces are passing through the point A. If you take point E, again two unknowns are passing through the point E. That's why it's better to consider a point such that at least, not at least, two unknowns should pass through the point. Then another unknown will be found out easily. So this is what all I should say about at what point we have to consider the moment for the easy purpose. Now, can you ask me doubts if you guys have any?
Sir, I have
Yeah, please.
only one doubt. Sir, in this problem, we
Yeah.
have just you have drawn the mirror image of the left section. But is it possible for the bigger problems? So,
Yeah, that's what I'm telling you. It might be possible. That too, I'm not guaranteed. But if they are possible, then you should utilize those conditions, isn't it? If they are not possible, then no one can do it, anything.
yeah, now it look like the actual problems. Our previous the
Yeah.
same pictures is same now. But in this case, if it is more than one panel, more than our any two panel, if
You
it
mean
comes,
this?
is it possible to draw the mirror image? This
You
is
mean
my
this?
doubt. No, more than two panels. More than two panels. A bigger one. Yes.
Like this?
Yes, sir.
Even I can consider, or even if it's separate here, isn't it?
Yes, we can separate. But how
Um,
about the trust we have solved for zero force member, the first problem also. The first problem, the trust look like a triangular pot.
Yeah, this one.
Ah, yes, sir. Is
Yeah,
it
yeah,
possible
yeah.
to draw?
No, that's one. In this case, these type of problems might be difficult.
Okay, okay, okay.
That's what I'm telling you is that it is not possible for all the types of trusses, but at least for the exam, they might, if they give you, they won't give you this type of complicated truss and they will ask you to solve it in within 5 minutes.
Okay,
That's what
okay,
their
sir.
motive
Okay,
is.
sir. Okay, okay,
Wherever it is possible, we have to utilize it.
okay, fine.
Understood?
Yes, sir.
Okay, other than that, now can we move on to find the portion member CE?
Yes,
So
sir.
for which type of section I can consider? Can I cut like this?
Yes, sir.
Then which one I should consider, left side or right side?
Left side.
Why? Because right side there are
Only
supports
three.
that we haven't yet found out. Sorry, I think the right. Yeah.
Sir.
Yes, please.
Sir, can you go to the previous slide, sir?
Yeah, please.
Sir, in this case, when we are taking section, while we are considering the other forces, we are taking all the members to the left side of the section, sir. But
Yeah.
for taking moment, we are considering right side of the section. Is it okay for that?
Easy. Section I have represented only this.
Yes, sir.
These are imaginary lines I'm saying. These are like pseudo forces, virtual
sir.
forces, virtual points. For summation of moments, you can take it at any point. Not
Okay, sir.
only here, you can take it somewhere point here also if you can represent it. If you know the dimensions, let us say if this point is some 9 meter and if this point is some, even you can represent it. It doesn't matter.
Okay, sir.
You
Okay.
will get the same thing.
This is possible only for moment, for taking moment,
Yeah,
right?
yeah,
Imaginary line should be taken only for moment.
Yeah. Even if you
Okay.
want to resolve it for summation apply, even if you talk about this point, then everything you have to consider, isn't it? For forces, it doesn't matter. They won't depend movement it upon this displacement or direction.
Okay,
Now,
sir.
what about the force in this member I can represent? This is what my force in the member BC, and this is what my force in the member. Did I miss something or did I mention it wrong? Opposite, sorry. So this is what my force in member CE, and similarly this is what my force in member EF. Here my force is acting in 20 and here my force is acting in 20. Let us discuss in form of wording only this problem, okay? Now, again, this is also sort of the same problem that we have discussed. Now, see, look at the forces along X first of all. Look at the forces along X.
There are three forces, sir.
What is it?
FBC,
FBC?
FC horizontal component,
Yeah.
FEF.
EF, right? Can we find any one unknown?
No, sir.
That's why if we use in this case summation fx 0, I won't write any equation because I'm not getting any one unknown directly. What if you write summation fy 0?
Yes, sir. FC can be found out, sir.
How many forces are coming into the picture? I think this is 10. How many unknowns? 20 and 10. They both are in downward direction.
1.
So what is the total downward direction? 20 plus
30.
40.
To balance this, the vertical component of FC should act in which direction? 20 and 10 are acting in down.
Upward.
Upward.
That means if I resolve this component, is it acting in vertical direction?
Upward.
Upward. So that should be equal to, I can say, FCE
FC.
if this
Sin
angle is theta, sin theta. So if I write summation fy, then I can directly find FCE, isn't it?
Yes, sir.
Again, 30 by sin theta, sin 45, 1 by root 2. So directly I am writing it as 30 root 2. Now, again, just for the first simplicity, I am just representing the virtual lines. This is what my point C. This is what my point F. Now tell me, out of these three forces, tell me the points where two forces are passing through.
E point and C point, sir.
If I take point E, what is happening? How many forces are passing through?
E and
E
EF.
is passing through, EF is passing through.
Yes, sir.
So if I take summation of moments at point E is equal to 0, then which unknown I will find out directly?
BC.
What is the remaining unknown?
BC, sir.
FB.
BC.
Similarly, what is the another point? Look at
E
this
point.
point.
EF could be found out.
You take summation of FC is equal to 0.
FEF will find out.
BC and FC will be 0. And what is another point? EF will be found out directly. Is it clear?
Yes, sir.
So that's why this is where the logic behind the method of sections. Wherever it is possible, you please try to identify the equations or points along which you can directly find out the unknown. Again, I am saying if possible. Why I am saying if possible? It might not be mandatory, or we cannot get like this for every type of trust. But wherever it is possible, you have to utilize them, and then you have to find out the unknown. If it is clear, can I give a simple example?
Clear, sir.
Let me give you an example then.
Yes, sir.
Yes, sir.
Solve it, please.
Sir, E and EF will be 0 because there is no force acting in the member.
Sorry. Can you please repeat what you said?
E and EF will be 0, sir. Because
No, I'm not. See, what I'm interested in
FBC.
FBC. I don't bother about other forces.
okay, sir.
I don't bother at all.
Is it 0, sir?
How you quickly found it?
Sir, we can take moment at the point H, sir, so that only the BC member force will act at moment H, sir.
No.
At the
Come
point
again.
H. If we take moment about H point,
Uh,
only the BC member that force will act at H, sir.
So
BC into 3, the perpendicular distance is 3, sir. That is equal to 0. So BC is 0, sir.
So no. Which section you have considered, left side or right side?
Left side, sir.
What
Left
about this force then?
10 kN acting on the joint.
What about this reaction then?
Okay,
If
sir.
you take left side, they will also come into the picture, isn't it?
Yes, sir. Yes, sir.
Sir, we can section on the members BC and CH and BH.
Listen to me. Forget about everything. And still you can say what is the force in member BC. How? Tell me first of all, in exam, will they ask you? They are already required is FBC. Will they tell you, okay, solve it by using method of sections and tell me the answer? Method of joints and tell me the answer. Competitive exam, it doesn't work like that, isn't it?
Yes, sir. They won't. They will ask only the member.
What about the
forces. They
force in
won't-
this member? Zero.
Is
What about the force in this member?
0.
0.
Zero, sir.
Everybody will agree.
Zero. Yes,
Yes,
sir.
What about the force in this member?
BG 0.
0. 0, sir. No force acting on the member.
What about the force in this member?
0.
0.
What about the force in this member?
0,
That
sir.
is also 0, sir.
Look at this joint.
C.
How many are connected? 3.
Yes, sir. But
So
not
BC also 0, sir.
How 3 members are connected? Already, what is the force in member CD?
will be 0.
Then what
CD
about
is
the
0 and CH also is 0, sir. So BC also is 0.
So how many zero force member? Any other zero forces are possible?
Possible, sir. Because
Look at the joint A. How many members are connected? 3.
3. But A equal to
Sir,
0.
AF also
A is 0. 10 kilonewton and AB. Are they collinear or not?
Yes, sir.
collinear, sir.
A
AF also
is
0. sir.
already 0. So if I remove it,
Yes.
what will happen? This is the 10. This is what force in AB. And this is what my force in member AF.
AF.
So what about this?
So AF also 0.
0. Then any other possibilities? What about at F? This is 0. This is 0. But this is possible. This is possible. This is possible. So we
Sir.
cannot judge them. So how many zero force members are there here? 1, 2, 3, 4, 5, 6,
8,
7,
sir.
8.
8 counting.
But answer is 0. But I need answer from you by using method of section. Can you solve it and get back to me tomorrow?
Yes, sir.
Don't go through any notes or any books. Already you might have found any similar problems or exact problem.
Sir.
I don't know. But still, just try with your own mind and let us discuss tomorrow.
Okay, sir.
Okay, sir. Okay, sir.
Okay, then if you have any queries, let me know, or else we can stop here.
No, sir.
Devi Perumal, kindly can you please respond or can you please interact with us? Anybody know about?
She is also attending, sir, one class.
He is also
Attend for our class, sir.
from
Previous-
the starting.
No,
Actually,
sir.
I could not able to identify her. That's why I'm just
For
Okay.
the other subject she was attending. Sir.
Other subjects. Okay, what did essay did to her? Okay. Anyway, okay. If you have any queries, let me know, or else we can stop here today.
Okay, sir.
Any
Thank you,
doubts?
sir. No, sir. No doubt, sir.
Okay, and next is that while in class, we are discussing, as I told you, the same thing. We are discussing either with respect to section.
Sir,
method,
only one clue, sir. Sir,
Yeah,
only
please.
one. Sir, if we want to find the method of section,
Yeah,
should we take the section right side of the section, sir?
you can take anything. But the thing is, unlike the previous case, what about your supports here?
This is indeterminate one.
Even you consider left side or even if you consider right side, supports will come into the picture or not?
It
Yes,
will
sir.
come, sir.
That
It will
means
come, sir.
if you want to find the, or if you want to solve it by using method of sections, first of all, you have
Please,
to find the support reaction. Then
Okay.
only it will solve, otherwise it's not. If you
Okay,
find support
okay.
reaction, then it's not a big thing to solve this question.
We will try, sir.
Okay, just try it. Okay, so let's
Yeah,
wind up here.
sure.
It's already beyond the 9. Okay, guys, thank you. Thank you so
Sure.
much.
Thank you, sir.
Thank you, sir.